You know, every time you stream a movie or save a photo to the cloud, you're plugging into this massive, invisible infrastructure. But have you ever stopped to think about what that infrastructure is really built on? It's not just code and cables. Today, we're going to pull back the curtain on the ethical compass that guides the very people building our digital world.
Right? We always hear about the brilliant code, the cutting-edge hardware, these gigantic data centers. But what's the actual foundation holding all of that up? Well, it's something more than silicon. It's a set of ethical commitments. This is the bedrock we almost never see, but we rely on it constantly.
And let's be real, the power we're talking about here is immense. The ability to shape how literally billions of people connect, work, and live, that power is in the hands of researchers. So that incredible influence has to be balanced with an equally incredible sense of responsibility. So what does that actually look like in practice?
Well, the very first principle is all about protecting people, what we're calling the human element, because it's so easy to forget that at the end of every single data point, every network packet, there's a person, and the number one ethical duty is to make sure they are safe from harm.
This brings us to a huge concept, informed consent. Now, this isn't just about getting someone to check a box and say yes. It's about making sure that yes actually means something. Researchers have to lay it all out, the what, the why, and any potential risks, before a single byte of data is ever collected.
So, this process, it builds a path to trust. It's a really clear four-step journey. First, you explain the goal of the research. Then, you're totally transparent about any risks. After that, you specify exactly how their data will be handled. And only then, once all that is understood, do you ask for permission. It's a dialogue, not a decree.
Okay, so you've got consent. Great. But protecting the person doesn't stop there. Think about it. We all leave these little digital footprints everywhere we go online. The next huge ethical challenge is making absolutely sure those footprints can't be traced back to us. And here's what that actually looks like. On the left, you see raw data, an email, an IP address, things that could easily identify a specific person. But on the right, you see that same data after it's been anonymized. All the personal stuff is swapped out for generic labels. The useful patterns are still there for the researcher, but the person's identity is completely protected. This isn't just a nice to have, it's a non-negotiable step.
Protecting individuals is, of course, the first big step. But responsible research also means you have to zoom out and use a wider lens, looking at the potential impact on all of society and, even the planet.
This principle sounds simple, but it is so profound. It's the core of what's called beneficence and non-maleficence, or to put it simply, do good and avoid doing harm. Every single research project has to be weighed on this scale.
A perfect example of this in action is something called penetration testing. The benefit here is huge, right? Researchers act like ethical hackers to find security flaws before the bad guys do, protecting all of us. But the potential for harm is just as real. What if those methods leaked? They could be used for actual attacks. So ethical research demands super strict controls to make sure that never happens.
And the whole idea of harm isn't just about data leaks or malicious code. There's a real physical cost to our digital world, a cost that we can measure in energy and resources.
This chart shows that hidden costs pretty clearly. Large-scale projects, like training these massive AI models, can consume a staggering amount of electricity. An ethical researcher has to think about this environmental impact. They have a real responsibility to try to be as efficient as possible, to minimize the footprint of their work.
All right, so we've covered protecting people and we've covered minimizing harm. But what holds it all together? What allows any of us to trust the results of this research in the first place? Well, that all comes down to two things: transparency and integrity.
These are the absolute pillars of that trust. First, being open about your methods so other people can check your work. Second, and this is a big one, never manipulating data just to fit a story you want to tell. Third, being totally honest about any conflicts of interest. And finally, being humble enough to acknowledge where your work has limitations. This integrity is the foundation of all scientific progress. So when you put all of these principles together, protecting people, doing good, being honest, you get something really powerful. You get a guide for navigating the incredibly complex challenges of modern technology. Look, this whole framework, it isn't some restrictive checklist that's designed to slow down progress. It's a compass. In the fast-moving, often uncharted territory of tech research, this compass makes sure that innovation is always pointing in a direction that actually benefits humanity.
And that leaves us with a final thought, a big question, really. Technology is only going to get faster, more powerful, more integrated into our lives. The real challenge for all of us is making sure our collective wisdom and our ethical commitment can evolve right alongside it. It's a question that everyone, not just the researchers, will have a hand in answering.